Today we'll be talking about the periodic law and the periodic table, part 3, the family or group that contains sulfur. We'll spend a particular amount of time on sulfur. The assessment criteria for this part 3 is to know the occurrence of sulfur, understand the structure and allotropy of sulfur, to know the sources of sulfur dioxide in the atmosphere, and understand its consequences, including the formation and effect of acid rain. Understand the need for food preservatives and know the use of sulfur dioxide for this purpose. Understand the role of sulfuric acid as an acid and as an oxidizing agent. Recall at least one process for the manufacture of sulfuric acid as an equilibrium process, and know its major uses as an industrial chemical, and understand the environmental impact of sulfuric acid manufacture. Let's look at the first assessment criteria. Know the occurrence of sulfur and understand its structure and allotropy. Sulfur, along with oxygen, are among the two most important elements in industry, the environment, and living things. Sulfur occurs as a polyatomic molecular solid. It's most oftentimes found in hydrides or oxides, so that means it's found with hydrogen or oxygen. Hydrogen sulfide is a gas formed when plants die and decompose, as well as animal matter. It's found in volcanoes, and it's found in deep sea vents. It's also used as a source of sulfur and in the manufacture of paper. Sulfur dioxide is a colorless gas also formed in volcanoes when sulfur meets oxygen, or wherever there is a sulfur-containing material. Coal has sulfur in it. It's used as a preservative of fruits and wines. It can be used as a reducing agent as well. It can remove excess chlorine from water or oxygen from petroleum handling tanks. Sulfur on the periodic table is the allotrope champion. It has more allotropes than any other element. The ability of a sulfur atom to bond to another sulfur atom creates numerous rings and chains. So therefore, the bond angles can go anywhere from 90 degrees to 180 degrees. Most oftentimes, we see sulfur as a ring of 8 atoms. The most stable allotrope is called orthorhombic S8, or sulfur. All other sulfur allotropes over time turn into orthorhombic S8. Sulfur's reactivity with different kinds of elements depends on the size, especially with halides. SF4 is extremely reactive. However, SF6, more fluorine, is almost as inert as a noble gas. The following video on the structure and allotropes of sulfur will give you further information on structure, bonding, and reactivity.
Structure and allotropes of sulfur. Allotropic modifications of sulfur. Sulfur exhibits different physical forms in nature. These forms are called as allotropes of sulfur. The 3 different allotropic forms of sulfur are rhombic sulfur, monoclinic sulfur, and plastic sulfur. Rhombic or alpha sulfur. Normally, sulfur exists in this crystalline form at ordinary temperature. It is soluble in carbon disulfide. All other varieties gradually change into this form on standing. It has a melting point of 385.8 Kelvin or 112.8 degrees Celsius. Monoclinic or beta sulfur. This form of sulfur has needle-shaped crystals. It is soluble in carbon disulfide and has a melting point of 392.2 Kelvin or 119.2 degrees Celsius. At ordinary temperature, it is not stable and changes into rhombic sulfur on long standing. On heating, monoclinic sulfur changes into rhombic sulfur at 369.4 Kelvin or 96.4 degrees Celsius. This temperature is known as the transition temperature. Plastic sulfur. If boiling sulfur is poured into water, it solidifies into a rubber-like substance called plastic sulfur. This variety is insoluble in carbon disulfide and water. It is unstable and changes into rhombic sulfur on keeping for long time. It does not have a sharp melting point. Molecular structure of sulfur. The allotropes of sulfur exist in a molecular form in which 8 sulfur atoms are linked to form a ring. This ring is non-planar. It is a puckered ring as seen here.
The next assessment criteria is to know the sources of sulfur dioxide in the atmosphere and understand its consequences, including the formation and effects of acid rain. Sulfur dioxide is a primary air pollutant. We've talked about sources before: volcanoes, burning things that contain sulfur in it, such as coal, smelting plants that turn sulfur-containing ores into metals, and places where sulfuric acid is made commercially. Sulfur trioxide is a secondary pollutant. It's formed in the atmosphere by sulfur dioxide meeting oxygen. Sulfur trioxide dissolves in water and makes sulfuric acid, H2SO4. If it dissolves in precipitation, the water as rain falls on the ground and acidifies the soil. It changes the pH and the balance needed for proper plant development. The following video, Sulfur Dioxide is Pollution, describes this process.
When there is sulfur in coal that is burned for electricity production, the sulfur combines with oxygen in the air to produce sulfur dioxide. This is also true for the combustion of oil for transport and industry purposes. This in turn combines with more oxygen to produce sulfur trioxide. In a humid environment, sulfur trioxide combines with water vapor to produce H2SO4 or sulfuric acid. This is commonly known as acid rain. The combination of these pollutants creates a synergistic effect which results in much greater negative impacts on human and environmental health. Human health effects include respiratory distress, which would severely affect those with respiratory issues, such as bronchitis, asthma, emphysema, and would be more prevalent in the young and old. Environmental health would be disturbed by lower pH levels in the waterways, and which can make the aquatic environment intolerable to many animal and plant species. Acid rain also burns the foliage of many plant species, making them open to environmental conditions.
Another assessment criteria is to understand the need for food preservation and know the use of sulfur dioxide for this purpose. Sulfur dioxide can be used as a preservative. It's used for dried fruits oftentimes. It has antimicrobial properties. That means it reduces the possibility of dangerous bacteria getting on the food. It's called E220 when used in this way in Europe. It maintains the color of the fruit and prevents it from rotting. Sulfur dioxide has been used in winemaking since Roman times. Romans would put candles made out of paraffin and sulfur inside empty wine kegs, and it kept them fresh and free from the vinegar smell, the end result of wine going bad. Sulfur dioxide is still used in some winemaking. It's measured in parts per million in wine. It serves again in its antimicrobial position to reduce bacteria and oxidation. It also helps to minimize acidity. Sulfur dioxide is responsible for the words contain sulfites that you would find on wine labels. Understand the role of sulfuric acid as an acid and as an oxidizing agent. Sulfuric acid is an important industrial chemical. It's used in a wide variety of processes, including the making of iron, steel, and aluminum. It's also used in making phosphate fertilizers. Over 1 million tons of sulfuric acid are made each year in the UK alone, with an additional 40 million tons being made in the USA. Worldwide production of sulfuric acid is about 180 million tons. Oxidation on the part of sulfur as an oxidizing agent works since sulfuric acid is a proton donor. H2SO4, 2 H plus ions ready to donate. Recall at least one process for the manufacture of sulfuric acid in terms of an equilibrium process. The process is called the contact process. We will show this process in this diagram, and then we'll show a short video afterwards to reinforce the contact process. First, air and sulfur is burned to form sulfur dioxide. These gases are mixed and cleaned by electrostatic precipitation. So we just have sulfur dioxide, no excess carbon. And then we mix sulfur dioxide again with oxygen gas to produce sulfur trioxide at a little bit above normal pressure and at a medium temperature with a catalyst. When we mix that sulfur dioxide and oxygen gas, we get a 98% yield of sulfur trioxide. With sulfuric acid that we have made before, we dissolve that sulfur trioxide and it continues to make it continues to make sulfuric acid. We can then take this concentrated sulfuric acid and dilute it as needed. And any unreacted SO3 gas, sulfur trioxide, is recycled to improve the percent yield and to create more H2SO4. Again, the following video shows the contact process.
Sulfuric acid is used in a wide range of processes. It is used in metal treatment, for drug manufacture, for paint, and the making of explosives. The sulfuric acid plant in St Helens on Merseyside, owned by Hayes Chemicals, makes about 600 tons of acid per day. The plant is close to the local motorway network. At the Hayes plant, sulfuric acid is formed by burning sulfur in a furnace to form sulfur dioxide. In a converter, the sulfur dioxide reacts with more air to form sulfur trioxide. In an absorber, the sulfur trioxide reacts with fairly concentrated sulfuric acid to increase the concentration of the acid. The acid is then diluted to the concentration needed by the customer. Some acid is recycled through the absorbers. Some is stored for sale. This is the Hayes chemical site. The sulfur is burnt in a furnace. Sulfur dioxide passes to the converter. Sulfur trioxide is fed to the absorption towers to produce acid of the required concentration. This is then stored for delivery by tanker. This tanker is delivering sulfur. It's obtained from local refineries where it's been recovered from oil and gas. It's transported as a liquid at around 140 degrees Celsius. The liquid sulfur is sampled before being stored for acid production. Air, the second raw material, is drawn from the atmosphere, dried and compressed. The sulfur is sprayed into a furnace where it burns in the dry air. Sulfur combines with oxygen in the air to form sulfur dioxide. The oxidation produces large amounts of heat. That heat is used to boil water to produce steam to generate electricity. The gas mixture, which leaves the furnace, contains sulfur dioxide and enough oxygen for the next stage. In the converter, sulfur dioxide reacts with oxygen to produce sulfur trioxide. The reaction requires a catalyst, mainly a vanadium pentoxide. This is most effective at 440 degrees Celsius. There are 4 beds of catalyst in the converter. The first catalyst bed converts about 63% of the sulfur dioxide to sulfur trioxide, and heat is produced. The gas stream is cooled before it passes to the next catalyst bed. Hot gas superheats steam from the furnace boiler. The gas stream passes through 2 further catalyst beds and the percentage conversion increases. Between each stage, the hot gases have to be cooled. By the third bed, about 95% of the original sulfur dioxide has been converted to sulfur trioxide. After this catalyst bed, the gas stream is led into the bottom of an absorbing tower packed with ceramic material. The rising gas meets a stream of hot sulfuric acid that runs down the absorber. The sulfur trioxide reacts with the water in the acid to increase the concentration of the acid to about 99%. The gas from the top of the tower still contains some sulfur dioxide and oxygen and is fed back into the final bed of the converter, after which 99.5% of the original sulfur dioxide has changed to sulfur trioxide. Less than 0.5% of the original sulfur leaves the stack as sulfur dioxide. The 99% concentrated acid is diluted with water to 96%, for example, and this increases the volume of the acid. This extra 3% is the volume of the acid that has been made. The acid concentration is checked by sampling. Besides sulfuric acid, the plant generates a large amount of heat, which is used to produce high-temperature steam and make electricity. Electricity is sold to the national grid. The production process is controlled and monitored from a control room. This dial shows the concentration of acid being produced in one part of the plant. Acid is transported to customers by rail and by road.
The industrial uses of sulfuric acid include its use as a powerful dehydrating agent, removing water from a substance, a powerful oxidizer. It's very corrosive. It can be used to clean metals in the correct concentrations. And it's used in car batteries and also in the bleaching of paper products and textiles. The car battery plant in Taldy, Corrigan uses large amounts of sulfuric acid. Sulfuric acid manufacture can have an effect on the atmosphere if sulfur dioxide is released to the atmosphere, or sulfuric acid mist, a combination of sulfuric acid and water. The principal source of pollutants are from the burning of sulfuric acid sludge, which creates SO2. Most of the SO2 made in a sulfuric acid plant is converted to sulfuric acid and recovered, but a portion of the chemical is emitted to the atmosphere. There are systems that can be put in place to reduce the amount of sulfuric acid mist, and sulfur dioxide. These systems are in place in many developed countries. Underdeveloped countries do not have as many abatement systems as do developed countries. Here are some questions to start your thinking. I'll have you look through them, complete the answers to them, and provide them to me when requested.